This is the test review, or one of the final test reviews for the stoichiometry chapter, right before the test. I made this worksheet up a couple of years ago, back when we used to have professional development days. So PBA may not mean anything to you, I just haven't taken that off. But these are some good questions, so let's work them out. And I'm actually working all of these out, so if you need to look at any one of these questions, by all means fast forward. Good luck on your test. And remember, for the steps for stoichiometry, make sure that you're going through all 4 steps for stoichiometry. And what I'm going to do on this worksheet is a little bit different than what I've been working out or how I've been lecturing. I'm actually not going to insert the numerical values in until the very end. So this might be a little bit of an interesting journey for some of you, but it may help some of you as well. So sit back, relax, let's get started. Number 1, it says calculate the number of grams of nitric acid that are needed to produce 1.45 kilograms of calcium nitrate from the above reaction. So make sure, again, you're going through the 4 steps, and always be talking to yourself through these 4 steps. Step 1, write a balanced equation. Well, in this case, I've already given you the reactants, and I've also given you the products. So we want to make sure that we balance the number of atoms. If I'm giving you a formula, like this chemical formulas, it's safe to assume that they are balanced. So we'll just go ahead and balance out the atoms. And by looking at this, this is probably the ugliest one of them all because we have 2 nitrates. So let's start with that one. So since we have 2 nitrates there, let's put a 2 right there, which now gives us 2 hydrogen. We already have 2 nitrates on both sides, so let's put a 2 there, which now gives us 2 chlorines. Over here we have 2 chlorines, 1 calcium, 1 calcium. That formula is balanced. Step 2, let's take what's given and convert it into moles. Now this is the amount that's actually given. But what I'm not going to do is I'm not going to put any numbers in to begin with. I'm only going to write the units down. And that's one thing that I'm noticing that a lot of you are not doing, is writing your units down. You're only writing numbers, or you're writing numbers and some units. Probably the most important thing for you to be doing while setting this up is writing the units. Then go back and put the numbers in. You'll find that to be a lot more interesting. All right, so if we know we have our kilogram amount, let's start with that. So I've got some kilogram amount. And when you're converting from kilograms to grams to moles, you don't necessarily need to write kilograms of calcium nitrate unless you're just dying to, but I probably won't give you enough room. So let's do that. So since step 1, write a balanced equation. Step 2, change what's given into moles. I need to change the kilograms into grams. Very good, because on the periodic table, your unit of mass is in grams. So if it's not the unit you're looking for, move that unit diagonally. So we'll put kilograms down here and grams there. Again, don't put any numbers there. And then what I'm going to do is convert the kilograms into moles. So again, if it's not the unit you're looking for, move it diagonally. So put grams here, and we'll change that number. That'll actually, we'll probably even move this guy over somewhat. I'll give it a little bit of room here. Yeah, we'll keep it right there. That'd be good. And we're going to go to moles of calcium nitrate. So now would be a good time to write your calcium nitrate down. And that is up in your balanced equation, which is being hidden right now. Now, we are not using the values from this until we get to step 3. We are still in step 2. So right now, we just finished step 2. And actually, I'm going to move you over just a little bit more. So again, all of this, which we don't have any numbers for, is step 2. Step 1, write a balanced equation. So there's step 1, write a balanced equation. Step 2, take what is given to you and convert it into moles. Okay, no numbers yet. Step 3, let's change the color here. Step 3, what we're going to do is we're going to get rid of moles of calcium, what is that? Calcium nitrate. And the question is asking for what here? Calculate the number of grams of nitric acid. So we'll put our moles of nitric acid right here. Now again, make sure that you know that that's nitric acid. I just gave it to you. Okay? And we'll come back and put those numbers in here in a moment. And since it wants to know how many grams, so I'm going to move my unit moles of nitric acid diagonally, and then we'll find out what the molar mass for that is. So here we go. Step 1, write a balanced equation. Step 2, take what was given to you that you can completely convert into moles and convert it into moles. Step 3, we're going to use the mole ratio. We want to get rid of moles of calcium nitrate to get moles of whatever it is that we're looking for. True, we're not looking for moles, we're looking for grams, but you have to convert it to moles because those are the like values that are on your periodic table. So we've got to get the values to what's on the periodic table. Then we'll get rid of that unit moles and then convert it into grams. You must show step 3 in every single problem. You may not have to show how to get moles in step 1. You may not have to show how to get moles in step 4, but you must show step 3. Okay? So now that we have the unit that we're looking for, in this case we're looking for grams, all the other units are going to cancel out. The kilograms will cancel out. The grams will cancel out. The moles of calcium nitrate will cancel out. The moles of nitric acid will cancel out. But we can't really get too excited about that just yet until we have some values in there. So let's take those away. Let's now put the numbers in. So from the problem, 1.45 kilograms. Which is bigger, a kilogram or a gram? Let's scoot that up. So a kilogram is bigger than a gram. And how many grams are in a kilogram? 1,000. Very good. Now, for any time that we are finding moles, and we're not using step 3, this is step 3, your value for the mole will be 1. So you go to the periodic table and find out what the masses for all these are. So calcium has a mass of 40.8 grams. Plus we have 2 nitrogens, which is 14.01 grams. Move you down just a little bit. Okay. Plus we're going to add it to 6 oxygens. And all of that will equal, let's get a number there. So 164 is the molar mass. So 164.1 grams. So that's what my gram amount is. Okay, so let's continue on. So now we need to put our values in for the mole ratio, and for step 3, we go back to the balanced equation. So for nitric acid, there are 2. For the calcium nitrate, there is 1. Okay. Then we need to change that into grams, and again, from the periodic table, there's 1 mole, and then we need to find the molar mass. So 1.008 grams plus nitrogen, 14.01, and then plus 3 oxygens. And let's find out what that is. That molar mass is 63.018 grams. Okay. So I think it might be very helpful for some of you to not write the numbers in at first and go ahead and put your complete units in. So once we have that, then it's simply up to us to calculate the values here. Okay, so now let's find out what all this is. And I got a value of 1,113 grams. Now again, if you were doing scientific notation or showing the correct number of sig figs, it would be this. Okay, so 1.11 times 10 to the 3 grams. All right, let's try the same thing with the next question. Okay, so number 2. Number 2 asks, calculate the number of grams of iron 3 chloride. So actually, let's box that in. Calculate the number of grams of iron 3 chloride. Okay, that are produced when a 275 milliliter, when 275 milliliters of a 3 molar solution of iron 3 sulfate reacts with magnesium chloride. Magnesium sulfate is also produced. So let's write the balanced equation. So it says calculate the number of grams of iron 3 chloride that are produced. So iron 3 chloride, so iron, and it has a +3 charge, and it's chloride, IDE. That means it's an element, and it has a -1 charge. So that means that there are 3 of those. Okay. And let's see here. Are produced when 275 milliliters of a 3 molar solution of iron 3 sulfate. So again, iron has that +3 charge. Sulfate, SO4, has a -2 charge. So that's not even close to being balanced. So we need 2 of those, and we need 3 of those. Okay. All right. And let's see. Reacts with means it's still over here on the left side. Magnesium chloride. So magnesium has a +2 charge. Chlorine -1. So that means we need 2 of those. Let's see if I can scoot that over just a bit. Okay. Also, it says magnesium sulfate is produced. So magnesium +2, sulfate -2, SO4. Okay. Now, what I didn't do on the last one, and I feel bad about it, I didn't write the information that we knew about one of these, or about these things. So let's go ahead and write that. So we have 275 milliliters of a 3 molar solution. Actually, let me move all this down. So I'm going to fast forward here. All right, so let's write what we know. We have 2.75 milliliters of a 3 molar solution. And the question wants to know, calculate the number of grams of our iron 3 chloride. Okay, I apologize for not doing that at first. All right, so step 1, write a balanced equation. Actually, let me go with purple there. Step 1, write a balanced equation. That is the ugliest one of them all, so let's start with that one. So it doesn't matter if you start with the iron or the sulfate. Let's start with the iron. There's 2 of those. So I'm going to put a 2 right there. So now I've got 2 irons on both sides. I have 6 chlorines now, so I need to get 6 chlorines, so let's put a 3 there. Now I have 3 magnesiums, so let's put a 3 there. So now I've got 3 magnesium, 3 sulfate, 3 sulfate. So step 1, write a balanced equation. It's done. Step 2, let's take what's given and convert it into moles. Now in this case, we actually have 275 milliliters of a 3 molar solution. So we have a volume and a molarity. If you have the volume and the molarity, start with the volume. So in this case, I'm not going to put the numbers in. We're going to go milliliters. And again, we want to convert the milliliters into liters because, again, when you look at molarity, it's moles over liters. So if we can cancel out the volume, we'll be left with our moles. So we're going to get rid of milliliters, convert the milliliters into liters. And once we have our liters, okay, our milliliters would cancel, we're going to move our liters down. That's where mole comes into play. That's where our molarity is going to go. So we'll put our molar value in there. So again, this is all step 2. Okay, all step 2. Now, what we need to do is go from step 2 to step 3. So this is moles of Fe2SO4 Okay, so we need to move our unit moles of iron sulfate down. So we'll put our moles of, actually let's change the color there. So moles, whoops. So moles of iron sulfate. And we are looking for moles of iron chloride, iron 3 chloride. Okay, so that is step 3. We're going to get rid of our units of iron sulfate. That's what all the volume and molarity is dealing with. Then we're going to change it into moles of iron chloride. So we're going to move that unit diagonally. Moles of iron chloride. And then we'll put the molar mass on top. So whatever that weighs. Okay? So that's not too bad. That's actually pretty simple. Put your units into play. So milliliters will cancel, liters will cancel, moles of iron sulfate will cancel, moles of iron chloride will cancel, and you're left with grams, which is exactly what we're looking for. So let's go ahead and put our values in here. So we start off with 275 milliliters. That's what's given. We have to do our conversion here. Which one's bigger, a liter or a milliliter? Very good, a liter. And there are 1,000 milliliters, or 10 to the 3 milliliters. So now my milliliters are gone. Liters, if I have a 3 molar solution, what that means is I have 3 moles for every liter. So I'm going to put my 3 moles up on top. So now my liters are gone. Essentially what I've done is I've canceled milliliters and I've canceled liters. So now I need to get rid of my unit moles of iron sulfate. So I need to go back to my balanced equation, which I have a 1 here. So 1 there. Actually, let's use a different color. So I have a 1 there, and the iron chloride has a 2. Okay, so now that I have the value there, now my moles of iron chloride are gone. Since I'm looking for grams of iron chloride, this needs to be a 1 because of whatever's on the periodic table. Again, when we're calculating grams for something, it's always for 1 mole, not from up here, not from the balanced equation. We only use the coefficients or the numbers in front of the molecules for step 3. That's the only time. So let's find out the molar mass. Iron is 55.85 grams. And we have 3 chlorines, so we'll add that to 3 times 35.45 grams. And we'll get a mass for that. The molar mass for that is 102, so I'm going to draw an arrow there. Oh, I'm sorry, 162.9 grams. Okay? So now we can calculate how much all this is. 267.63, so I'll say 268 grams. Question number 3. Calculate the volume in milliliters of a 1.75 molar solution of phosphoric acid, which is H3PO4, needed to completely react with nickel metal in a single replacement reaction to form 25 grams of hydrogen gas. Nickel 2-phosphate is also created in this reaction. All right, so there's a lot going on here. Let's organize our thoughts. First of all, what is the question asking? Well, we're going to calculate the milliliters of our phosphoric acid. Now, there's some information that's given here. We have a molarity, but we're looking for the volume. So if we're looking for the volume, we don't even want to think about starting with that, because there's no way, just like in the last question, that if we do not have a volume, there's no way we can find the moles of this. So we're not going to even look at that number just yet. Okay? We do have 25 grams of hydrogen gas, so that's kind of nice. So let's write down what we know. So again, I want you to calculate the volume of phosphoric acid needed. So that means that it's going to react with, so phosphoric acid, H3PO4, okay, needed to completely react with nickel metal, okay, and nickel's Ni, in a single replacement reaction. So what that means is nickel is going to replace the hydrogen, and the hydrogen's going to get kicked out. And again, we're going to assume that that mechanism or that action is going to happen. So that's what's going to happen. And so hopefully on the other side of the problem, we're going to have nickel with the phosphate. And it says that nickel 2-phosphate is also produced. But more importantly, let's get the hydrogen out of there. So hydrogen, when it's all by itself, so when the nickel kicks that hydrogen out, the hydrogen, it ends in GEN, is going to be diatomic. Do not write a 3 for the hydrogen. All right, this is here because phosphate has a -3 charge and each hydrogen has a +1. That's why there's a 3 there. All right, and then we also said that nickel phosphate is produced. In this case, nickel has a +2 charge. So don't be selective and look and say, oh, well, nickel has a 2 or a 3 charge. I'm going to pick the 3 charge. No, it says there's a +2 charge. So use +2. Phosphate has a -3 charge. So we need to balance those out. So looking at this, we're going to need 3 nickels and 2 phosphates. Okay? So that's pretty good. So let's write down what we know. So again, we have 25 grams of hydrogen gas. And the question wants to know how many milliliters. How many milliliters if we have a 1.75 molar solution? Okay, so there's the information. Now we don't need to look at the question anymore. Okay, step 1, write a balanced equation. So let's see here. What's the ugly one? That one looks like it's the guilty one. So we have 3 nickels. Actually, let's go with phosphate. We have 2 phosphates. Let's put a 2 there. So now we've got 2 phosphates. How many hydrogen do we have? 6? Good. So we'll put a 3 there. So now my hydrogens are balanced. So now it looks like we just need to balance the nickel. Put a 3 there. Okay, so everything's balanced. So again, do not even think about starting with this information here. Since we're looking for the volume, it has to be at the end. We can't put a volume at the beginning if we don't know it. So start with the thing that will get you to moles. Except I'm not going to write any numbers down. So let's write our units. So we will start off with our grams, and this will be of hydrogen. Okay. And we're going to convert the grams of hydrogen to moles of hydrogen. Very good. So we'll put moles of hydrogen, and then whatever the molar mass of hydrogen is. So that unit, grams of hydrogen, will cancel out. So this is all step 2. Step 1, write a balanced equation. Step 2, change what was given into moles. Step 3, we're going to get rid of our unit moles of hydrogen and go to moles of phosphoric acid. Very good. We'll put our moles of H3PO4 right there. Okay, so again, not putting any numbers in. The question wants us now to get the volume in milliliters. So at this point right here, step 3, if I were to stop, my units would be, grams would be gone, my moles of hydrogen would be gone, and I'd be left with moles of phosphoric acid. Well, I have a molarity for phosphoric acid, and again, molarity, when we extend the page here, if I have a 1.75 molar solution, that again represents 1.75 moles for every liter of that solution. So if it's not the unit that you're looking for, and we're not done yet, then we're going to move that unit diagonally. So we're going to put our moles of phosphoric acid down here, but we need to put a value there. Well, if you have a 1.75 molar solution of phosphoric acid, that would be our number, which means that we're going to take this molarity and invert it. Okay? So again, remember that the things that are vertical represent or are equivalent to each other. In 1 liter of the solution, I have 1.75 moles of phosphoric acid in there. That's what I have. But again, the question wants to know what is the volume in milliliters, so I need to go 1 additional step. Put my liters down here, my milliliters there. So if I were to go through, my moles of phosphoric acid cancel, my liters cancel, I'm left with milliliters. So now let's go ahead and put the values in. So we know we have 25 grams of hydrogen. Put it in. 1 mole of hydrogen, because again, we're converting the grams into moles. So 2 times 1.008 grams. From the balanced equation, phosphoric acid has a 2. My hydrogen has a 3. The number here, again, is 1.75 molar, so we can put our 1.75 in there. Coming over here, for every liter, there is 1,000 milliliters. Again, if some of you are struggling with doing stoichiometry, I highly recommend do the units first, then go back and put the values in. It's going to keep you from doing a lot of dumb things, which a lot of us like to do. So once we have that, let's calculate. See what those values are. In this case, I get 4,724 milliliters. Number 4. Number 4 says, calculate the mass in grams of water vapor produced when 75 milligrams of pentane gas, which is C5H12, reacts with excess oxygen in a combustion reaction. We should know what the products are in a combustion reaction. Carbon dioxide and water. Same things that you breathe out. All right, so let's go ahead. So we're calculating the mass in grams of water produced. Now don't freak out if it says water vapor. All right, it's just still water. So let's see here. So we have our pentane, C5H12, and it reacts with oxygen gas to produce carbon dioxide and water. Again, the same waste products that you produce. Okay? All right, so let's write down what we know before we balance or do step 1. So 75 milligrams of pentane, 75 milligrams, reacts with excess oxygen. Even though we're not doing limiting reactants, that means that we have more oxygen than we need in a combustion reaction. So once let's calculate the mass in grams of water. So mass of grams of water. So the only thing that we need with the carbon dioxide is to have it to balance out the equation. All right, so let's move that up because we don't need to see the question anymore. So let's balance this. All right, start with the hydrogen. We have 12 there, put a 6 here. That's an even number. That's a good thing. So now we have 12 hydrogen, 12 hydrogen. Carbon, we have 5. And that's okay because we still have an even number of oxygen. So my carbons and my hydrogens are balanced. Now I have 10 plus 6 times 1, which is 16. So I can put an 8 there for my oxygen. I am balanced. All right? So step 1, write a balanced equation. Step 2, start with what you know. And in this case, we have milligrams of pentane. And we're going to change those milligrams of pentane first into grams before we go to moles, because again, we have to go through the proper steps there to get it to the units that we need. So milligrams down here, grams on top. Again, we're not going to put the values in yet. And then again, we're going to get rid of grams to get our number of moles. And in this case, it's moles of our pentane, C5H12. All right, let me move that gram over a bit. Whoop. Okay. And so at this point here, that's all step 2. So step 2 is to change what was given into moles. We're going to go to moles of, or we're going to get rid of the moles of our pentane. So we'll slide that over. And we are looking for moles of water. So our mole ratio, step 3. Okay. All right, so since the question wants to know how many grams, we need to go one more step, change those moles of water into grams of water. Okay, so looking at our units, milligrams will cancel, grams will cancel, moles of pentane cancel, mole of waters cancel. We're where we need to be. So let's get rid of that. Okay, so let's go back and put our values in. So the milligrams, we start with 75. Which one's bigger, gram or milligram? A gram. How many milligrams in a gram? That's right, 1,000. Again, we're finding molar mass, so that's 1 mole of the pentane. So we have 5 times 12.01 grams, plus we have 12 times 1.008 grams. So we can find out what all that is. Let's find out that molar mass. Pentane has a molar mass of 72.146 grams. Okay, that's kind of nice to know. Let's continue on. So our mole ratio, again, the values come from our balanced equation. So we have 6 waters. That's where we put our 6. Here we have a 1, so we put a 1 there. Once we're finished with our mole ratio, we want to convert it to grams, so it's always for 1 mole, because again, what are the values on the periodic table? And water has a molar mass of 18.016 grams. Okay, so we can calculate. Let's find out what that's equal. So that equals 0.112 grams of water. Okay. All right, let's look at question number 5. Question number 5 says, calculate the mass in kilograms of aluminum metal. So again, we're looking for the mass of aluminum metal in kilograms produced when 168 grams of lithium reacts with aluminum carbonate in a single replacement reaction. So aluminum is produced and lithium reacts with, so that means plus sign, aluminum carbonate. So carbonate, CO3. Charge on aluminum is a +3. Carbonate is a -2. So that means we need 2 aluminums and 3 carbonates. Okay. Now again, what is happening? Well, the lithium is coming in and it's kicking the aluminum out. That's why we have the aluminum standing all by itself over here. And hopefully I didn't give it to you, but if we're going to have lithium kick the aluminum out, what other product is formed? That's right, we're going to have lithium carbonate. And so again, looking at the charges, lithium has a +1 charge, carbonate -2, so that means we need 2 lithiums. Okay. All right, so there is our equation, not balanced, but let's write down what we know. So calculate the mass in kilograms. Oh. Looking for kilograms of aluminum, and we have 168 grams of lithium. Okay, this is actually a pretty standard type question, one that we worked out numerous times. Nothing really too difficult about that, but let's scoot that up. All right, so step 1, write a balanced equation. That one is the ugly one, so let's start with that one. So we have 2 aluminums. Okay, now carbonate, we have 3 of those, so let's put a 3 there. 6 total lithium, so put a 6 there, and we are balanced. All right, start with what you know. In this case, we know we have grams of lithium. Okay, and let's change those grams of lithium into, that's right, moles of lithium. So move your grams diagonally, and we'll put moles of lithium on top. Okay, and then we want to get rid of the moles of lithium by using the mole ratio. Okay, so again, that's all step 2. So now we're into step 3. We're going to get rid of moles of lithium and go to moles of aluminum. Now we're going to get rid of moles of aluminum and go to kilograms. So we got to go to grams first. So grams of aluminum. And then one more step, grams into kilograms. So look, really nice. If we cancel our grams out of lithium, and we cancel our moles of lithium, cancel our aluminum, or I'm sorry, moles of aluminum, and then grams of aluminum, we're left with kilograms. Pretty nice. And I kind of like this. I'd rather see some of you who are struggling start with your units first and then input the values. All right, so now we can put our values in. We have 168 grams of lithium. Lithium has a molar mass of what? 6.94. From the balanced equation, 2 aluminums, 6 lithium. From the balanced equation, 1 mole is 26.9698 grams. Okay, and then which is bigger, kilogram or gram? Kilogram. And there are 1,000 grams in a kilogram. 1,000 grams in a kilogram, not 1,000 kilograms in a gram. All right, so type away. So 0.218 kilograms. So not too bad. That's a pretty standard type question. All right, let's look at number 6, and I think that might be it. So last question, number 6, and save the best for last. Ooh, what do we got? Ooh, this is a fun one. You're gonna like this one. I don't think we've worked one out like this before. Okay. Number 6 says, determine the volume in milliliters of a 5.6 molar lead-2 nitrate solution needed to completely react with 755 milliliters of a 3.33 molar solution of sodium carbonate. Wow, look at this. Isn't that a fun one? We do have a volume and a molarity, and we also have another question asking us to find the volume of a different solution. So we're having two solutions that we're reacting with. This is fun. This is, however, not a limiting reactant problem because we don't have a volume for this. So it's not a limiting reactant. But let's still do the 4 steps. So step 1, write a balanced equation. So we have determine the volume of lead nitrate needed to completely react. So we're going to have lead nitrate. So PB, here, lead nitrate, and it's lead-2 nitrate, so nitrate has a -1 charge. That means we need 2 of those. Completely react with sodium carbonate. So sodium has a +1 charge. Carbonate, CO3, has a -2, so we need 2 carbonates. And doesn't tell us what else is produced. But what kind of reaction is this? Very good. That is a double replacement reaction. So what's happening is the 2 metals are going to switch places, or switch partners more appropriately. So in this case, we're going to have lead with carbonate. So lead with carbonate, and lead has a +2 charge, carbonate a -2. Good. And then we're going to have the sodium with the nitrate. Again, always write your metals first. So sodium nitrate. All right. Let's get rid of that arrow there. All right, so let's write down what we know, and there's a lot that we do know. So we have 755 milliliters of 3.3 molar sodium carbonate. So we have 755 milliliters of a 3.33 molar solution. Question wants to know how many milliliters of a 5.6 molar solution. Okay? All right, so once we have that, we don't need to look at the question anymore. Now, don't freak out if you should happen to see a question like this on the test. It's probably not too likely that you will, but you should be able to handle a question like this if it should appear in front of you. Would we start with this information here? We would not, because we don't have a volume. This one, we do have a volume and a molarity, which will get us moles. So that means that we're going to finish with this. So that is the value that we're going to start with. But before we can do that, we have to balance the equation. So step 1, write a balanced equation. Which one looks ugly? There really aren't any ugly ones, so it doesn't matter. Start with this one. Sodium, there's 2 of those. Put a 2 there. So now we have 2 nitrates. We're balanced. Okay, so actually let me change the color of that one just to let it pop out a little better. All right, so we've got 2 of those. Okay. All right, so again, we're going to start with the amount of our sodium carbonate, but I'm not going to write numbers. I'm still going to stick with the units. So we're going to start off with our milliliters. Okay. And we're going to convert the milliliters into liters. And then again, we're going to get rid of our unit liters by using the molarity. So moles of sodium carbonate. Okay. Excuse me. So that's all step 2. So changing the volume into liters, liters times the molarity gives me moles. Step 2, convert what's given into moles. Step 3, we want to get rid of our moles of sodium carbonate, the stuff that we started with. And we are looking for moles of lead nitrate. Okay. And if we stopped right there, we'd have moles of lead nitrate. But we're looking for volume. So again, we're going to take that mole of lead nitrate and move it diagonally. Okay. And recall that 5.6 molar means means that we have 5.6 moles of our particulate in every liter. So we're going to take that and invert it. So we're going to have liters on top. Okay? If you're given a molarity and you're looking for a volume, you know you're going to use that at the end. Flip it. Invert it. Okay? Then the last step is it wants it in milliliters. So change those liters into milliliters. That's not so bad. That's actually a fun question. So let's write some values in here. So we started with 755. Which one's bigger, liter or milliliter? Liter. How many milliliters? 1,000. Our molarity is 3.33. From the mole ratio, wow. Carbonate, oh, that's a 1. Lead nitrate is also a 1. That's a bummer. Our molarity from here is 5.6. And then the last step is, which is bigger, a liter or milliliter? And then let's solve. So 449 milliliters.